Welcome to AP Plus Podcast. I am your guest, and these are your hosts.
Anto.
And Phil.
What's up?
Yeah.
We're finally back,
I know.
people.
It's only been a month. Come on.
We took a long break. But we're only back because new science is
Big announcements.
coming out.
Yep.
Proving that gravitational waves have been detected.
Yeah,
And obviously showing off that Einstein is still the man.
Closing the book.
And nobody can beat him.
It's like the last part of his theory has been observed.
You know, okay, the first thing I think about every time something with Einstein comes out is that there are people getting paid to prove Einstein wrong. And they have failed their whole lives, you know?
Yep.
And they still get paid to do it.
And they still get paid to do it.
I want that job.
I know.
What a crazy thing.
You never really have to perform. You can keep failing your whole life, but it's fine.
And that's like how it should be, you know? We should have people trying to prove him wrong.
Yeah.
No, we should. It's just, it's so crazy that, I mean, it's only 100 years and
he's been right, but obviously he's been improved upon by more science and more research.
They've deepened their understanding.
Yeah, I mean, and I think that's, you know, if he was a scientist, I'm sure he'd be stoked, you know, that people took it further than he did. But also it's super impressive what he was able to do, considering he didn't have all the tools and all the additional information.
Yeah.
So solving this before it happened.
Yeah, it is pretty incredible.
Yeah.
So essentially what scientists found out today is through this, how do I call it? I don't know. It's called LIGO, which is a
laser. I know the start is laser.
L
is for laser.
It's equipment.
Yeah,
it's not equipment. It's a station, rather.
Yeah.
That's the word I'm looking for. Okay.
Yeah.
So anyway, scientists nowadays are at this station called LIGO, and they found pulses of waves that bounce through mirrors, essentially, and instead of them being the same, and
we have two lasers shooting through mirrors.
Yes, lasers.
And when the gravitational wave hit it, it caused a misalignment.
Yeah, so they split, they polarize, they depolarize it when they go through the mirror, and then they cover a great distance, which helps in the accuracy of it. When they come back together, they phase cancel. When the gravity distorts those distances, the phase cancellation breaks up, and they start to see dots.
There was a tiny separation.
Yeah. And,
tiny separation. We're talking about a fraction of a proton now. And this is the kind of technology that we have these days, that size, and mind you, this is a wave coming billions of years ago, that we still picked it up, and we could still test it, which proves this guy, who's never seen it before, Einstein I'm talking about, correct again.
It is funny because, like you're saying, it's so tiny. It seems like all the stuff we discover nowadays is tiny because we've already found everything that's big. So it seems like all we're going to ever have are things that are just barely measurable by, like you're saying, fractions of a proton.
I know.
It's like exciting, but also like kind of sad because we've already discovered all the big stuff that it's like, you know, a spectacle.
Yeah.
So now we just solve all these little tiny things, like something happening billions of years ago in a far off galaxy.
I know. I mean, essentially everything we're looking for is tiny. I mean, we're trying to find life, which could again be microscopic. We're always looking for in our oceans, like really, really tiny stuff. We're looking for cancer cell research, which again is so tiny and so small that, I mean, or even our computers are at the quantum level.
I know. Yeah, exactly. Everything's
quantum computing.
Tiny.
That's fascinating.
Yeah. You know, and in essence, we are, everything about.
We're tiny.
We are tiny. I mean, you
stuff.
look at you think space is big, but in reality, all we see is such a small part. It is another tiny factor.
Yep.
The amount of galaxies out there, it's like it's unfathomable. It really is. It's not.
Is.
I mean, I don't even know what the number is, but
what was it? Trillions or billions of trillions?
And trillions. That's how it's always described. It feels like one of those. I don't know if it's a real number.
Yeah,
or if
I think
it's
just because you're just trying to make it relatable.
Yeah, Phil and I were talking about that. Is billion, trillion a real number? Like, is it a zillion, or do they say it because half of us are just retarded?
I think they're just saying it to simplify, just to show just how big it is.
Yeah.
Sometimes they might get somewhat close, by actually saying a billion trillion, because a billion trillion is a number, a real number. It can be, but I have a feeling that they usually just say as emphasis on it's huge. And honestly, we don't even know our galaxy as our observable universe.
Yeah, that's like
There's
that's one of the hard
a
things about it.
Yeah, it could be infinite. It's probably not, but it could be. Our universe could be infinite.
I
even.
know. It's such a hard thing to wrap your head around. That word, which somehow simultaneously is so big and so small.
I mean, you can't really even
Infinite.
imagine a universe with or without infinity. It's like if there's no, even like the beginning, before the Big Bang, it's not time, but it's something, and that's infinity.
100 billion.
100 billion galaxies in the observable universe.
Yeah, exactly. As far as we know today.
Galaxies.
Yeah, galaxies. So we have stars, which are billions
and
billions
planets and asteroids and
the amount of things in this
dwarf
universe.
Planets. Isn't that what Pluto is?
Yeah,
labeled as dwarf planets.
Yep. There's a lot of them. Even ours. There's tons of those. Tons.
I know. So of course we're putting out more and more satellites into space, which is getting more and more data that we're just trying to see and collect as much data, even if it is the tiniest thing. Like this gravitational waves, it's so tiny, yet it now helps us do more math.
And it gives us confidence too in continuing research. Like we just, like that Lisa Pathfinder thing. It's basically just building upon the stuff we just learned. Like we found the gravitational waves in September or something.
Yeah,
and then they launched this. Who knows when? I wonder if they launched before or after because it just got there in January.
Yeah, I don't know what role it plays.
Yeah, but it's
timeline of it.
But it's like the first step for additional research into gravitational waves.
The Lisa Pathfinder is the one with balancing the gold, right? In a free fall.
It has these two things. Yeah, they're basically just trying to make sure they can successfully stabilize some things that well.
It's a
because eventually,
but
it's a test in order to do the laser system, which is going to have a triangle basically shooting lasers from what was it like?
They're a million kilometers away.
A million kilometers apart. That's right.
A triangle a million kilometers.
So we've only done the first test. We haven't actually sent up the real things. But if this test works with the stabilization, then they'll know that they can do it.
So like the Lisa Pathfinder is it's an incredible like situation that they put it in. So they need to find some kind of gravitationally neutral zone. And so one of the places for that, I tried to think of another one. I couldn't think of one. So I guess there is no other one, is this space in between the Earth and the sun. There's like a pocket where the gravity cancels each other out enough so we're it's one of the most neutral spaces. So we sent the Lisa Pathfinder out there to hover in this space. And we can do these experiments in this. I guess it's designed for one primary experiment, which is where it floats these two golden cubes inside of it in free fall.
That's stage one, of the test, and then that's going to be.
And then so the idea is
the real thing.
It's really just to approve, so they can build an even larger apparatus that connects itself with lasers from very, very, very far distances.
Yep.
Yeah, it's so crazy that we just build these. I'm guessing they're close to billions of dollars now, like satellites and all this stuff. And they only do one mission, yet it's such a stepping stone for the next mission. Like these satellites that just go around and observe like Saturn or Pluto. All their mission is to get there, and then beyond that is take photos. And then, we always wish like we could go down and dig up stuff, but that's not their mission. They're literally not programmed to do that.
Well, what was the satellite that went by Saturn, and it started, or was it Jupiter? It started examining the moons, and then it was Saturn.
And
then after they found that one of the planets was teeming with organic molecules, they attuned the instruments differently to try and pick up and analyze this planet, even though it wasn't originally designed.
I do think that it was originally designed to sense some atmospheric elements on those planets.
But they're like really versatile.
Exactly.
They can do a lot with these probes. They don't just kind of they're really advanced.
They've definitely probably built a lot of things into these things just in case. Like they're not their primary goal, but they must have had ideas about what they could possibly find, and then they were like, they could modify it from there. But
Enceladus. I can't even say it.
Enceladus. Yeah,
right.
It's Saturn's moon that potentially could have life, which is like a snowball, but underneath the ice or the layers of ice, there's looks to be hydrogen water.
Yeah,
and of course, liquid water could always produce life no matter where it is. And it is the only one, according to scientists, it's the only other rock, I guess I'll say, that has the perfect building blocks.
There's another
life.
one. There's the moon. There's the moon of Jupiter that has a liquid water in her as well. There's 2 planets that have liquid water, or 2 moons that have liquid water right now. One at Saturn, one at Jupiter. As that's what we believe.
According to that last video we
That's
watched.
pretty crazy.
No, the last video literally that's exactly what I'm using as reference.
Oh, really? I thought he was just saying Earth.
No, there's only one on Saturn, and they were saying that one has potentially an ocean that's bigger than all the water here on Earth.
Right.
But the other one also, they theorize has liquid water. And then there's a third planet that has a liquid, but it's not water. It's like a whole different...
In our solar system.
Yeah. Yeah.
But what's super special about this one in Callitus is that it spews out...
Yes, yeah.
It spits out essentially... or could be bacteria and life and
organic molecules.
Yeah.
Water and organic molecules. It literally spits it out like a pressurized, smoke bomb.
Yeah, exactly.
As it orbits Saturn, and any asteroid that passes through this disk that it's been leaving behind for millions of years would pick up some of its stuff. It's essentially like a panspermia machine.
Mm-hmm. Yeah, exactly. Like, what if an asteroid went through that as it spits out, some life? An asteroid goes through it, collects some of that, and it continues on this mission, and it crashes into a rock, and that's how life on Earth was made or something. Yeah, you never know.
That would be bizarre, because a lot of scientists think that we could be related to like Mars life, but it'd be weird if we were related to some far out
Saturn moon or something.
Okay,
that's where we actually came from.
Do you think that would be cool, or do you think it would be boring? Because personally, I think it'd be boring if we found the same life on this moon, on Saturn's moon, as on Earth. I think it would be boring.
If it would be boring to me if we knew that it was spread, from here or to here.
Yeah.
If we found it and it was the same, but we know that it had its own like genesis moment, that would still be incredible information, because then we would know that like DNA is a law, or is a fact of nature, rather than it just being here on Earth.
At the same time, if we didn't find, this quote unquote the same life on this moon and Earth, it could be because we didn't actually find it on Earth yet. It could be just buried so deep in one of our oceans. Dude, our ocean's pretty fucking deep, dude.
No, there's plenty we don't know about here.
Yeah, it's actually really, a lot of people don't realize that the deepest oceans are actually really hard for us to explore. Yeah. It's not the same as space. Once you get to a certain part in space, it's really just how far can you travel.
Yeah.
But with the deep oceans, it's not like that. It's not just pressure that you're dealing with too, though. Corrosion and other kinds of elements.
Absolutely.
So that we don't know a lot about the ocean. It's pretty fascinating, actually, to think that it's like right under our nose.
It's so vast, dude. Like every time I go surf and I think about how big the ocean is, and I just turn around and I just see like a little bit of land, and it's just I'm just nothing, dude. And I can't even touch the bottom. Obviously, I can't even hold my breath to touch the bottom where I'm surfing.
Oh, sure, yeah.
Yep. It's just and just imagine how. Or what is down there, like on the Mariana Trench, the deepest part of the ocean. Who knows what's there?
James Cameron.
He was, yeah. He was there.
He left a clone down there. If you go down there, he's just like, yo, get out of here.
Did Einstein write that, or was that just, I don't know. No.
Who was that man? It was Einstein. But yeah, I mean, the gravitational wave thing, that's pretty cool. I'm pretty excited about it. It's interesting that because there's still people that don't really fully even grasp it or accept that like space-time can be warped.
Yeah.
But the gravitational wave is literally warping space-time as it's going through.
Yeah, exactly.
And part of why it's so significant is actually that I mean, because at first I didn't really realize it was that big of a deal, but these instruments that they're building, they're making them analogies to telescopes.
Yeah, they're talking about listening. But not through sound, but like through gravity.
Yeah, so like whereas previously we use telescopes and we take pictures, now we're using them kind of like microphones and we're recording
that's a good point. They're almost like big strings. These lasers are almost like big strings, and they're being plucked.
And gravity is such a huge key. And I think it's a really interesting. Every time we learn a little bit more about gravity, I keep finding it more and more fascinating. Like this, finding, like what, like it could help us.
It's going to affect our space travel,
what if
hugely.
what if we can eventually harvest gravity someday, or I don't know, make it like run our cars or something stupid like that? Who knows what we can do? Or,
what if we could ever create gravity?
Yeah,
that's
like artificial
really
gravity.
Artificial gravity.
And that's one of the hard things with like colonizing Mars or Venus or any of that is that the gravity issues are vast. Which, by the way, screw Mars.
Yeah. Unless we can
Team Venus right here. Hashtag
but
Team Venus.
What if we figured out artificial gravity? What if we found a way of
exactly.
creating suits that could, at least for your body's health, mimic gravity? So your bone density and things wouldn't be lost.
I mean, the reason why you're saying Team Venus,
I've been on an anti-Mars kick just because everyone likes Mars and it's fun.
Well, you're saying that because our time in space, it actually degrades our bones and muscles.
Yeah, no,
we're talking about gravity.
Legit case. Bad. It has low gravity. We can't really do anything about it. I also really recently realized that it has barely any atmosphere, so it's really unmajestic.
Right.
Go take a look at some of the sunset pictures.
It's very much a rock. As much as people don't want to think of it that way.
Yeah, there's no wind. It's like you throw a feather, it falls on the ground. It's just like you will be living inside facilities for millennia, or if not forever. Go Venus.
Yep.
Yeah, I mean,
sunsets, cloud cities.
Pascals, Mars was 600 pascals, and Earth's was
100,000.
100,000. Just for an example.
So that means Mars has 0.6% the atmospheric density.
Yeah, we're talking 600 versus 100,000.
Yeah.
And imagine what that could do to your body of being on there. Space. Astronauts go up there for a month and they degrade 1 to 1.5% of their bone density.
That's because of the gravity, though, not so much atmospheric pressure, I don't believe. Because atmospheric pressure, your human body's always going to be experiencing our atmospheric pressure, because if you don't, you die.
We'll be in suits or facilities all the time.
Exactly. So, like on the space station, I'm assuming the atmosphere is pretty close to 100,000 pascals.
Yeah, I imagine it's just similar to Earth.
But then the gravity on Mars is, what was it?
It's almost equal to...
The gravity of Mars is much less. What was it?
It's much less.
I forget what it was. It was
but that's the problem with it. That's one of the main problems with it, is just that you... I think it's less than half.
Yeah, it's less than half. It's not as bad as obviously nothing, but...
it's 3.7.
It's roughly about, what is that, like 40% or something?
But and gravity here is 9.8. So it's a third.
It's a third.
Okay, yeah.
All right. But
roughly.
It's a huge problem over generations or a lifetime type span.
Exactly.
We can send astronauts into low gravity or missions. Mm-hmm. But even then, you're really kind of getting... There's options. There's other options.
So this is what I got confused about. Venus is actually pretty close to us. Venus is 8.8.
Venus is really close.
Venus has harsh atmosphere.
Huge amounts,
Which
93 times.
And it's like so dense and hot, and
which is where we come. Which the cloud cities. That's where the cloud cities come from.
So, we couldn't live on the surface.
So basically, we can live on rafts of regular air.
Yeah, of our atmospheric pressure.
Yeah,
and we float like, what was it, 50 kilometers up in the sky? And
they even have series solutions for stabilization, tethering.
That's right.
Stuff like that.
And even maybe you don't even need a tether. What if you could just float around?
Yeah, I don't know.
Or we'd still have engines probably.
Yeah. I don't know exactly.
Push it around.
I don't really know
the high atmosphere
of it. Yeah,
because if you're floating that high, I wonder how much like wind and stuff affects you. How much you're getting pushed around. Because if the atmosphere is light enough up there that it's equal to here,
maybe you might just chill. Even if there's like a hurricane under you, you might be so high. I don't know.
Yeah.
So we're just in a hot air balloon. Or not a hot air balloon, sorry, a blimp.
Blimp,
exactly, kind of like
much.
Blimps. But imagine just huge like webs of blimps, like a huge net of blimps that connected together.
How can we like go through one bubble to the next?
Tubes, maybe. You know, maybe it could be
Yeah,
two pressurized tubes,
I
or
love
our
tubes.
atmosphere, just everywhere. And they can make them look cool. You know, they don't have to look like big silly.
They have the,
limbs.
they have the.
Or we could do like Tarzan vines where you like swing.
Oh, there we go.
That'd be pretty badass.
I was thinking about the airport. You know, like the paths or whatever you just stand on. It just,
Oh yeah, yeah, those things are pretty awesome.
The tracks,
you can
rather,
stand
whatever.
still.
Well,
or
they
you-
could have big platforms on top, like big airstrips, airports that float on top of the balloons.
Or you just have to jump and be a badass. And you're
Yeah.
like, Johnny didn't make it. So that's how we prevent people from getting like super fat and ugly, you know? You have to be able to
Aw.
jump the distance.
That's pretty rough, man.
I mean, what year do you think that would happen in?
Going to Venus? Yeah.
Like, no, I mean,
I
what year would we make these cloud cities?
Like on Venus, though?
I mean,
Yeah,
probably
wherever,
for
just
another, not for another 100 years. I don't think.
Yeah, I mean, probably not.
I don't know if we'll. Like,
just
if
like-
we go to a
it's like-
planet, it's like going to be a huge. We're going to have a massive reason to.
It's going to be like
send
going to
people there.
Antarctica. You know, it's just not. It's not going to be just people. We might have a station there in 100
Yeah.
years, but I don't see anything beyond a scientific.
And I
extinction.
always make the case for like I actually think robots are going to do a lot of this stuff.
Yeah.
That's a good point.
There will be a certain amount of like, well, we're going to have to put some feet down on places, and it's just going to be significant. But in the long term, the actual idea of colonizing a whole separate planet, it seems a little, unless we're threatened. You know, like climate change
Yeah.
destroying us, we're migrating. That makes total sense. But if that's not happening, I don't know. It's hard for me to really like see a whole human population separated.
I know.
Yeah,
Planet
no, that
from
seems
planet.
too much.
And you know, I mean, it's
Yeah, that'd be crazy.
Yep.
It blows my mind when everyone when I always love to ask the question how long, because today essentially it's been 100 years since Einstein's been around. Do you think
yeah.
and so from him going from where he was to where we are now, could you imagine going from where we are now in 100 years to Cloud City?
Yeah.
I don't know. 100 years seems really small to me. It
Yeah.
seems like, of course, I'll be dead, but to me, in my mind, I just can't imagine 100 years, maybe 200, maybe 250.
I would buy it longer. I would buy it longer. Yeah, I could see it being longer. I think I was being kind of.
I think 100 years,
fun
I
with
think
it.
we'll be like completely content with robots and cars will be.
Oh, okay.
not
Let me put it
as-
this way: in 100 years, we'll have Asimos running around on Venus and Mars that you can put on a VR helmet and see what they're seeing.
And experience it through their
that-
eyes.
Okay,
In
that I
100
can
years,
see.
that's what we'll have. But maybe,
Yeah.
another 250, 400 years from now, maybe that's when we'll actually
We have,
be
like-
like separating mankind
Yeah.
into two species: one that has left the Earth and the ones that will stay behind. You know what I mean?
And I think that's pretty far away, even maybe
Yeah.
further. You know, like that seems the actual separation of a species.
Missions,
actually-
that's a whole nother thing.
Yeah,
I'm
missions
talking,
is totally
like,
different.
like families to have babies and never come back.
Yeah, I think that's really far away because, I mean, assuming we don't like destroy our planet super fast, I mean,
Yeah.
we're going to be living out in space or we're going to be living on Earth.
And the weird politics of it too. Like, what if the very first generation of kids are born? They're like, "Hey, let's go back to Earth."
Yeah, exactly.
Like, they all want to go back to Earth. Like, what? How's that? I mean, I don't know. It's,
No, that's a good point though, because if it's like shitty life up there, it's not
Yeah.
even right.
Yeah.
So
it ain't right.
Raises
Yeah,
the question:
right.
Do you think that would? Do you think that would generate a new era? Do you think we'd like do a time shift? Because for me, hold on,
yeah, sorry, you go for
I'll
it.
just finish this thought. For me, the only time we'd change, so we're in, obviously we're in the year 2016. The only time we would change the year or whatever is when we met alien life.
And that's actually exactly.
So that would be. I would do
leave to
post-
No, I think or
I would
leave
do
to colonize new worlds.
pre-contact and post-contact.
I think
do you
that's
think-
what Star Trek does. I believe is they have some kind of light time system that's based on.
Maybe when they invented
Contact?
warp drive,
Yeah.
or
Because right now we're obviously running on the Jesus Christ was born, and that's
Yeah.
why.
we're running on Jesus Christ.
Jesus
I love
Christ.
that. Yeah,
Well,
and
and
he's almost out of fuel.
And I think about like without that, like everyone's agreeing, quote unquote, that's 2016. And in China, obviously, it's been the new year, and it's the year 4714. According to science, what year would it be? Or again, would this start us a new
Yeah,
year?
yeah,
Would we
what does
just
science say
just
about this
continue
one?
on until
Well,
we?
You know, that's interesting because I think the problem is that when you look at the year 2016, that's really a date that's used for human dating. You don't use that to date the universe.
But China is doing human dating,
No, but
and it
I wanna
says
know the sun in BC.
4,714.
No, exactly. Yeah. Well, the thing is they that's the Chinese New Year, but they do also acknowledge our New Year as well.
Okay.
Because it's the general system that's used.
So yeah, we got everyone on board.
We kind of, I mean, not, we, I guess.
You think there's like some really, really old people that don't believe it's 2016 and they only believe it's 4,700?
In China, I absolutely believe there's people in China because you got to remember, I mean, 'cause that's based on probably some emperor or something.
Yeah, and it's
like
not untrue.
The modern the most modern dynasty.
You could make a logical argument to actually, it's
I agree. I agree with this number. I'm not saying it's a wrong number.
Sure,
it's just
yeah.
I don't write it on my paper. I obviously say today was the February 11th, 2016, I'm
going to be a rebel. I'm going to start writing Chinese time.
Could you imagine?
You're going to confuse
And just
people.
argue with everyone.
What do they write?
Who questions it.
Do you think China has to write 2016?
I believe they do normally for things that are like related to business and things.
Especially because we do so much trading and it would be so confusing.
Yeah, absolutely.
Like,
but ultimately, you could have a super simple algorithm set up that just fixes this.
Yeah.
Like if they typed it in there a year, like Google probably does it.
Yeah.
Oh, I know.
What
How
year
about,
is 1984 in the Chinese year?
I have a question for everyone. We'll pass it around. What year would you start?
Like, what would I base the start on or
you
time
base
on?
year zero from?
Well, the problem is that I don't think we're there yet in our knowledge, but it would be probably something nice, like maybe like the birth of civilization or something, But unfortunately, it's such a gray period because you go from slowly. It's such a slow transition.
What would you do?
It's really hard.
I don't. Yeah, I think it would have to have an event that really triggered it, but in like a really
the asteroid that killed the dinosaurs.
but a nicer one, like a happy.
Okay, mine. I thought about this question before. Is the oldest Neanderthal. So if we find an older one, we just go back.
But the thing is Neanderthals aren't even like as old as like us.
Well,
like humans.
It's the closest thing to a human, right?
But humans existed before at the same time as Neanderthals. So like, but I would say like the same thing, but maybe humans. But like you're saying, we keep finding things a little bit older, bit older.
So we're always changing it.
Yeah, like
maybe
right now, like
update it like every year, like literally, come January 1st, it could be a different number.
I mean, I do think you still just need to base it on something, like
roll the dice.
I mean, it is kind of unfortunate that it's based on the birth of Jesus, because people will always use it as a power thing, like saying
if we base it on the Egyptians, they're so much older, dude.
But they're not the oldest though. Mesopotamia was first.
Exactly. Okay, so is that what you want to base it off of?
Well, right now, I think 10,000 years ago is the birth of agriculture, which is very much in line with the concept of a civilization, of people actually settling and working things out. So, I mean, you could roughly say something like that, but that's even before Mesopotamia.
If NASA is listening to our podcast, what year is it in science terms?
Yeah, or
please, NASA, listen.
Here's an idea. What about like when we invent fusion reactors? Because
we could start over.
Yeah,
we could start a new.
Because that would be a clear line of like us being a type 1 civilization. At that point, they feel like that's the most power that we can harness on our planet before it's time to actually.
That's the next era.
Because it's doing the same thing that the sun is doing. It's basically the same process in the sun.
We've harnessed the power.
Not nuclear fission, but fusion,
True
which
fusion,
is commonly confused. But fusion is the one that's in a future
or
time.
when we invent the magical cold fusion.
Oh yeah,
that will never exist. But no, that'd be good. I'm totally for a reboot of time, because I think that kind of dating is really only super significant to a somewhat recent group of people. Once you start getting like millions of years, you don't want to write a million-year date. So like every 1,000 years or something, roughly, when an event happens. I think
we could right now. Technically, we could be in the internet era. That was a huge. That's a huge thing, and then maybe we go to fusion.
But then I don't want to credit Al Gore for our
I know.
Yeah, that would be
Al
basing
Gore.
it from one deity to another. Jesus Christ to Al Gore.
Oh no! I don't know if I want to trade.
The internet era, also known as half man, bear, pig. The internet era, also known as man, bear, pig. Also known as half man, half bear, half pig. I mean, yeah, we could always break it up into eras. You know, we go to internet, we go to
Like
fusion,
year
we go to
5 since the fusion era.
intergalactic, travel, intergalactic travel.
And I was actually wrong.
Yeah.
Star Trek uses star date, which I'm not actually sure how they get that number.
Warp speed or something.
Oh, if we ever invent warp speed.
Yeah.
Yeah.
But I do also think that like if we ever do meet another species, like if they,
that would also
especially
be
if they
pretty
come to
appropriate.
us,
Yeah, that
we'll be
that
like,
is the one.
like how do you guys date things?
Yeah.
Yeah.
Like, is there
No, and they're
something
and they're
then-
like from the great Unok.
yeah, exactly. the son of
Yeah.
Legock.
His name is just Christ Jesus or something. Or
No, it's actually Jesus,
no,
dude.
Oh,
They actually praise
It's
Jesus.
straight up Jesus.
Oh my
man,
God.
That would fuck everybody's mind,
Dude.
Oh my!
I would have so much praying to do.
Seriously,
Fuck,
I'd be
dude.
like,
I would
wow.
do, yeah, dude. The world would be just Christian.
It's just Jesus
Oh, man.
spelled backwards or something fucked up. We're
no.
like, oh my God, we see it.
Inverted Jesus.
Yeah. We're like, dude, we met that guy. Like, he's coming around.
He's
Like,
going around to all the planets, man.
dude, you're like, you haven't.
Did you guys kill him too? It's like, no, we didn't kill him. He gave us the secrets of the universe.
Oh.
That's what happened.
No, we didn't kill him. The Roman. Yeah, we killed the people who killed him.
Yeah, that's
They
true.
were bad.
Yeah, they're the bad
It's
guys.
like the Space Cash episode.
And Hitler killed a lot of Jews.
we got him too.
Do you know this guy named Hitler? Because we all fucking hate that.
That's what our world creates. That's why we took so long to advance as a people.
That's crazy, guys. Oh man.
So
But yeah, that would. I mean, just the vastness. Like, yeah, if we ever actually made contact or discovered an alien race, which it's funny. We statistically think it's impossible for it not to be there.
yeah, but also
Which is amazing we haven't found
it's
it.
unlikely that I mean it's not. There's no reason for us to believe that we'll ever meet them.
Yeah. Oh, right. Meat. Yes.
Or yeah, but definitely. I mean,
we just know it's there, but yeah, we haven't detected it in any
Yeah,
way.
yeah.
And I think where you're going is like the projections of our possibilities of even detecting them isn't the best.
yeah,
We don't have that much to work with.
Yeah.
Even an observation from light is only so much.
It even goes back to the whole thing about like we could be a very young species. We could be
Yeah.
one of the first, early species or first planets to kind of start having life because of the way our sun is. We're actually slightly old compared to a lot of these star systems that are out there right now. So, for the ones that are big and not bigger, because big stars don't last that long. So we could be in the beginning.
Yeah, we could potentially actually be
Yeah.
one of the first.
So all the living things that exist could be at our level of development or less.
Yeah,
exactly.
right.
It's like, there's no way of
So
knowing.
we might be.
I know, because everyone thinks they're ahead.
Yeah.
But in reality, it could just be like a tadpole, like
Yeah.
just so small.
Or it's like we could be either like nothing, or we could be literally the pioneers.
Like we are
of the
it. We
universe.
like to think that some crazy alien race is going to show up in a spaceship and be like, "This is like
Here's the
crazy.
answers.
Yeah, here's the tech you've never imagined." But we might actually be that species. Like,
Yep.
we're the one that's going to show up on another planet.
our
potentially.
robot creations will spread knowledge
Really-
throughout the universe.
We're gonna
It's
fly
pretty
around.
badass.
We're gonna start
Hey.
probing everyone else's butt. And
Yeah.
just like secretly though, so no one
It's like
finds
that-
out.
That's
Put
why
them right
we're
back
so
in the
afraid of it
bed.
happening to us, because we know that's what we're going to do when we find other people.
Everyone
We're
hates getting their butt touched.
projecting our desires onto the aliens.
We don't want to be the penetrated.
Yeah, exactly.
That's the whole action.
We want to do the penetrating.
Oh my god. All right, guys. I think that's it for
Yep.
today. We're crazy. You're crazy.
All right.
Everything's crazy.
That's true. All right. Have a good day.